So in this problem, we're talking about a soft drink company. It knows that it has 42% market share in a particular region. The company's marketing department conducts a blind taste test with 100 people at a mall in the region. We're using normal approximation to calculate the probability that fewer than 40 of the people will choose their brand. So they're asking us to make the determination, the probability that X is going to be less than 40. All right. Now, because this is a discrete random variable, we can actually convert that over into a more meaningful value, or at least more familiar anyway. This is the same as, because it's a discrete random variable, it's the same as saying the probability that X is less than or equal to 39. All right, whenever we use normal approximation, we want to correct for continuity. So corrected for continuity, since it's a right bound, we would say that we're looking for the probability that X is going to be less than or equal to 39.5. All right, so that's what we're looking for. In order to figure that out, we need to know first what kind of situation it is. Now, because it's normal approximation to the binomial, we'd verify that the four conditions are valid: fixed number of trials, fixed probability, independent events, two outcomes. So in this case, we have a fixed number of trials, 100, that's verified. Fixed probability, 42% market share in decimal form, 0.42. Independent events, we have to make that assumption because I don't know the ins and outs of the psyche related to soda preferences, but I can assume that if we're going to make it work with this technique, that we'd have to assume the independent events. Two outcomes, they're either going to choose the brand or not. All right, so then next up would be computing the mean. So mu is equal to NP, which in this case would be 100 times 0.42, which is 42. Sigma would be equal to the square root of NPQ, or NP times 1 minus P. So 100 times 0.42 times 0.58. So I can just run those numbers real quick. So about 4.936. All right, so I'm going to compute the z-score associated with the 39.5. So z of 39.5 is going to be equal to 39.5 minus the mean of 42 divided by the standard deviation of approximately 4.936. All right. Now, just for the sake of cleanliness here, let's see here. Can I do this? Group that. No, would have been nice. Nope. For the sake of cleanliness, I'm going to just type it all in one shot. Minus 42 over the square root. So I'm just going to retype 100 times 0.42 times 0.58. And so we're looking at a z-score of approximately negative 0.507. All right, so that tells us that we're looking for the probability that z is going to be less than or equal to negative 0.507. All right, so I'll use my normal distribution function with a mean and standard deviation of 0 and 1, negative infinity to the value we just came up with, which, if you want, you can just call this like a equals. And then, I mean, you could call it z equals too, honestly. I'm surprised I didn't think of that. And then pop in the z here. A little bit more accurate that way. All right, so we're looking at approximately 0.3062. All right, so I'm going to get a little snapshot here of the corresponding work, pop it on in. Yeah, it's not the best looking diagram I've ever made, but still better than what I can do by hand, I'll tell you that. And it's honestly, it's better than anything the TI calculators are going to put out. So, yeah, it's super tiny, but I just wanted to have the work in there to justify it. All right. So the next question, same idea, except now it says exactly 40 of these people would choose their brand. All right. So we're using normal approximation to calculate the probability that exactly 40 of them are going to select that brand. So a lot of the stuff is going to be the same. We get our fixed number of trials, all that good stuff. The mean and the standard deviation are going to be the same. Now I just need to figure out what is going to make up my z-score. Well, if it's exactly 40, we got to think about what that would mean in terms of an interval. All right, so we're basically saying that it's not less than 40, it's not greater than 40. It's it's 40. So what we could say is that we want to find the probability that the x value is more than 39, but less than 41. That creates an interval, all right? But if we're talking about discrete values, again, we could think of it as being, and this is going to sound weird, being greater than or equal to 40, but also less than or equal to 40, which is very strange, but I'm going to write that. All right, because on the low bound for our continuity correction, we know if it's a right endpoint that we subtract 0.5. If it's, I think I said right endpoint, I meant left endpoint. If it's a left endpoint, you subtract 0.5. If it's a right endpoint, you add 0.5. All right, so that's creating the 1 unit of area around the value 40. All right, now we've already figured out the z-score corresponding to 39.5, so now I just need the z-score corresponding to 40.5. So what I can do here, because this is going to be my low bound, call this z sub 1. And I'll just do a quick duplicate, call this z sub 2. And make this go to 40. So we got our z-scores, so approximately negative 0.304. So I'm looking for the probability that z is between negative 0.304 and negative 0.504. I think, yeah, I almost definitely put those backwards because they're negative. Whoop. All right, so the reason I sub these back, hold that thought.
Well,
yeah, what's up?
a question for number 9.
Sure.
If it says triple integral, does that mean there has to be 3 integrals?
Yes.
Okay, just making sure. Thank you.
No problem. All right, well, that scared the living daylights out of me. So anyway, we're going to find, by using these subscripts, the area between z1 and z2, z1 being the lower bound. Let me just make sure that that's the case. So I'm going to pop in the Z1 here. And I'll pop in the Z2 here. And I get a little sliver of area. And that little sliver of area is exactly what the doctor ordered. So we're talking approximately 0.0744. All right. Any rounding variation in the possible answers is due to, I'm sorry, any variation is due to rounding. But that's okay. All right. I don't know if I'll be able to get all this in there. Get some of it though. Still better than the old days where you actually had to draw all this stuff out. Now, the old days could be coming back if it turns out that, you know, they say, oh, well, the AP exam, you got to do everything by hand, you know. Then we'll have to cross that bridge when we get to it. But for now, enjoy it while it lasts. A little copy pasting, you know, all the good stuff. So where did I put it? I put it here, it looks like, and there it is. All right. So the Quizizz had 0.0743 as a choice, but that was because of some rounding along the way. All right. And the last one, it's estimated that 10% of the flights entering New York carry undeclared goods. Use the normal approximation to calculate the probability that a search of 500 randomly selected flights will find more than 60 with undeclared goods. All right, so it's a sad moment because it's like, I started really getting used to the mean and standard deviation of 42 and 4.936. I wanted to continue working with that so I wouldn't have to recompute, but alas, here we are. All right, but I am going to copy paste this and say, you know what? Here we go. Let's take a quick look. 500 randomly selected flights. That sounds like a fixed number of trials. Fixed probability, 10%. Independent events. Yeah, I got to assume it, but I would think so. And 2 outcomes. You're either going to carry undeclared goods or not. So we're looking for the probability that the flights are going to find more than the selected flights will find more than 60 with undeclared goods. All right. So we're looking for the probability that X is going to be more than 60. Because it's a discrete random variable, that's the same as saying X is greater than or equal to 61, which because it's a right bound, right, that would be the same as saying X is greater than or equal to 60.5 for the continuity correction. All right, we need a mu, which is NP, 500 times 0.1, that's going to be 50, sigma, the square root of NPQ. So 500 times 0.1 times 0.9. All right, so 50 times 0.9 is going to be, what, 45 under the radical. So we could say 3 radical 5 just to make things a little cleaner. I mean, I'm going to totally double check that in mere moments. But, you know, for the sake of, like I've been saying, cleanliness, it might not be the worst idea. So let's take a quick look. 500 times 0.1 times 0.9 under a radical. Is that the same as saying 3 radical 5? It is, so we're good. All right. So I need a z-score corresponding to this value here of 60.5. So z of 60.5. So 60.5 minus 50 divided by 3 radical 5. Get an approximation there. I'm going to wipe out one of these because I'm not going to need them both. 60.5, 50. Put put the 5 here, put a 3 in front. So we're looking at about 1.565. 1.565. All right, so that's going to correspond to the probability that z is greater than or equal to 1.565. I still have that little subscript of 2 there. That's fine. Really doesn't make a difference. I'll just make this the subscript of 2. It's the left endpoint. Might have said right endpoint before. Left endpoint. And then we want this to be infinity. You just type in infinity and it comes up. All right, so 0.0588 if you round it to 3 significant. So again, little variation due to rounding, but that's okay. Got to expect that. Right, I mean, you shouldn't have to expect it, but you sort of have to, because the AP folks, they use other forms of technology. Sometimes they don't use technology at all. Sometimes they use probability tables, right? And they do it with a 4-function calculator. So, you know, there's going to be some little wiggle in the final answers, and if you're prepared for that, then you shouldn't have a problem. All right. So there we go. That's close enough to the final answer, and there it is.